Hello everyone. My name is Divyaranjan Das. I am pursuing BSc Honours in Data Science and AI from IIT Guwahati. Today I will be presenting my term project 3 titled Food Waste Prediction, Demand Forecasting and Inventory Optimization. Before we begin, here is the agenda for the presentation. In this presentation, I will cover the introduction, problem context, tools and technologies used, dataset and data validation, source code, output and results, evaluation metrics, and finally the summary. So starting with the introduction, food waste is a major challenge faced by restaurants, cafeterias, hotels, and food service organizations. Inaccurate estimation of customer demand often results in overproduction, excessive inventory, and increased food wastage. To address this issue, I developed a data-driven system that combines demand forecasting, waste prediction, and inventory optimization. The system uses historical sales records, weather conditions, event information, and operational factors to generate forecasts and recommendations. In addition, the project includes a class KPI for real-time predictions and a Streamlit dashboard that allows users to interact with the system and make informed operational decisions. Overall, the project demonstrates how predictive analytics can support efficient and sustainable food service management. Next, we will move into the problem context. The main challenge in food service operations is balancing food preparation with actual customer demand. If too much food is prepared, it leads to waste, inventory losses, and higher costs. On the other hand, preparing too little food may result in shortages and customer dissatisfaction. Factors such as weather conditions, holidays, special events, and changing consumption patterns may demand forecasting difficult. Traditional planning methods often rely on manual estimates, which may not capture these variations effectively. Therefore, an intelligent forecasting and optimization system is required to support better inventory planning, reduce waste, and improve resource utilization. Let's look into the tools and technologies used. For this project, I use Python as the main programming language. Pandas and NumPy form the foundation for data manipulation and pre-processing in the platform's development. Scikit-learn was used for machine learning, workflows, and model evaluation. XGBoost and Random Forest regression enable robust demand forecasting and accurate food waste prediction. Job-leaf serialization and Flask API enable efficient model deployment and real-time prediction delivery. Streamlit interactive dashboard for users to perform predictions and review analytics easily. Now we're moving to the dataset and data validation. The dataset consists of approximately 20,000 food service records containing historical operational information. The features include meal type, food item, quantity prepared, quantity sold, quantity wasted, temperature, rainfall, holiday indicators, event indicators, previous day sales, and previous day waste. Before training the models, a comprehensive data validation process was performed. Missing values and duplicate records were removed. Date fields were validated. Business rules were checked and outliers were identified to ensure data quality. Additional features such as day, month, weekday, and weekend indicators were also created to improve forecasting performance. Now we'll look into the source code, for which I will be opening my VS code. The first one is data validation file. The first component of the project is the data validation pipeline. At this stage, the raw dataset is checked for missing values, duplicate records, invalid dates, and inconsistent entries. Business rules are also enforced to ensure that quantities sold and wasted do not exceed quantities prepared. Outlier detection techniques are applied to identify unusual data points. This process helps improve data quality and ensures reliable model training. After data preparation, the next step is model training. For demand forecasting, I use an XGBoost regressor trained on factors such as meal type, food item, weather conditions, event information, and historical sales. The target variable for this model is quantity sold. For food waste estimation, I used a random forest regressor. This model considers operational and environmental factors, along with quantity prepared to predict expected food waste. Feature engineering techniques are applied by extracting temporal attributes such as day, month, weekday, and weekend indicators to improve forecasting accuracy. Once demand and waste predictions are generated, they are passed to the inventory optimization module. This module calculates safety stock, recommend inventory levels, procurement requirements, waste percentages, and estimated cost losses. Based on predicted waste levels, the system classifies operational risk as low, medium, or high, and generates recommendations such as preparation, reduction strategies, and inventory adjustment. This component transforms model outputs into actionable business decisions. To enable real-time usage, I developed a Flask API that accepts operational inputs and returns demand forecasts, waste estimates, and optimization recommendations. On the top of the API, I built an interactive simulate dashboard. Users can enter operational data, generate forecast, view optimization reports, assess waste risks, and identify cost and saving opportunities. This makes the platform accessible and user-friendly for operational managers. Now we'll look into the outputs and results of the project. So let me just run the code, simulate, run dashboard. So I named it as FoodOptima platform. So the dashboard consists of 4 tabs: the home, where you can find a little bit about the dashboard. Then I have the predictor tab, then the analytics, and the last one is the about tab. So here you can find the models, features, and technologies and benefits. So the main one is the predictor tab. So where we'll get the prediction, the reports, and the recommendations. So let me just choose the categories. So for the meal type, I will select dinner. Let's say select chapati. Let's say the temperature is 35 degrees Celsius. Rainfall is about 10. Previous day waste like 17. Unit cost 10 rupees. Prepared this previous results. So you can also select if there is any holiday or any event. Like if there is a holiday, you can select one, and if there is a event, you can select one, or else it will be 0. So the date is auto selected, that is 29/07/2026, and let's generate the prediction. So here we'll get the prediction that there will be 324 demand. The waste prediction is 60, and inventory used will be 324. Safety stock will be 32, and here is a recommendation that you can reduce the preparation by 18%, and the risk is medium. So this was the prediction. We can check the inventory report where you can see the procurement detail and like how much waste we can save, and the cost also that we can save. And the next one is the recommendation. Like you can see, this is the moderate waste rates. Expected waste is 60 units, and so we can reduce 18%. So the action plan will be accordingly. Like we can prepare 324 units. Potential waste saving will be 60 units, and potential cost saving will be 597. Now let us look at the evaluation metrics. To evaluate model performance, standard regression metrics were used. The first metric is mean absolute error, which measures the average difference between actual and predicted values. The second metric is the R-squared score, which evaluates how well the model explains variations in the target value. These metrics help assess forecasting accuracy and the overall effectiveness of the prediction models. The result indicate that historical sales, meal type, weather conditions, and event indicators significantly contribute to forecasting accuracy. Now we'll move to the summary. To summarize, this project successfully developed an integrated platform for food demand forecasting, food waste prediction, and inventory optimization. The system combines data validation, machine learning models, inventory optimization logic, Flask API, Streamlit dashboard to provide real-time operational insights. The platform helps organizations reduce food waste, improve inventory utilization, lower operational costs, and support sustainable food management practice. As future work, I plan to incorporate advanced forecasting models such as LSTM networks, integrate real-time US data, support multi-location inventory management, and deploy the platform on cloud infrastructure for large-scale adoption. At last, here is the URL for the GitHub repo, where you can find the detailed code of this project. I hope this presentation provided a clear overview of the project. Thank you for your time and attention.